Hey guys, today we'll be solving lead code number 21, merge two sorted lists. It is an easy question. Before I get to the question itself, I will first explain the cases that we have to consider, right? The best way to go about it is just to use two pointers in the sense that one keeps track of list 1, the other keeps track of list 2, okay? So if we have, let's say s over here, when f is equals to s, then we want to add both, right? You want to add both because it would not make sense to move s to 3, let's say, and then only add 1, right? Because now we have lost the 1. So add both, immediately add both. And when you've added both, then just move on to the next ones, right? S and f as is. Now the next case, when f is less than s, then, well, since it is a sorted array, we want the lower value first, right? So we will add f in this case, right? And once we've added it, we will move it forward. Now keep in mind that the two lists are sorted, so 1 2 4, 1 3 4, both of them are sorted. When you move your pointer, you will always get a higher value. So now we've added f, s points to 3 and f points to 4. We could say s is less than f, or you can just say it's like a else, right? So s is less than f. In that sense, well, move 3 in and bring it over here, right? Now they both point to the same thing, and we go to this condition over here. So we end up with a 1 1 2 3 and a 4 4, which is the answer. Okay, so now I'll first get to how we approach this. So in terms of code, when you have something like this where you have to like add and keep track of stuff, I would usually suggest having an empty, well, just having an empty list first. So we would have like a dummy, right? It would be like a blank node, and we will also make a pointer answer to it. So let's say answer sits at dummy right now, right? And I'll say f is, let's just say list 1, okay? So it is pointing to list 1's head right now. S is pointing to list 2's head right now, okay? Now when we're making these checks, the one thing in common is we need both f and s. So we'll do while first and second, right? I'll just keep writing it in a shorthand, much more easier. While f and s, consider it first and second. So if f dot val is equal to s dot val, that's the first case we talk about, right? We append both, right? But it's not so easy to append both. So what we will do is, essentially we want something like this, right? When we have this, when you do answer dot next to equal first, okay? So we said answer, move from here, move to here. Don't consider this right now. So when we had this list 1, we said answer essentially now just plugs itself into this, okay? But and when we do answer dot next, so it has to move, right? It has to move itself one ahead. It has to sit over here now, because otherwise we would just be sitting at answer and we would just keep modifying this one node over and over, and that wouldn't work, right? So we have to move answer. But now answer and first both point to the same node, right? So any operation that you do, so when you do answer dot next is equal to second, then what you've effectively done is, when you had these two lists, right? And now that answer and both first are sitting at the same point, and you said answer dot next is second, you've cut this and you've added this, and you've essentially lost track of everything in your first list. So how do we avoid that, right? We want to avoid that so that we can keep tracking it. The best way, just store it. So store the reference. So I'll do another underscore dot next, and I'll say f dot next for that. I keep writing first and second, just bear with it. Yeah, so first we store it, okay, then we move our answer to that, we move our answer one ahead, then we say answer dot next is also second, move our answer one ahead again, and now when we want to move the pointer first ahead, we will just do okay, f next. And same for s, we don't need to really worry about it, just do s dot next. Next condition, so when f dot val is less than s dot val, right? Well, first thing, we want to now point our first to that answer, and it's pretty simple. So this time we don't really have to worry about messing up the reference, so just move our first, move our answer, right? And just keep in mind that the ordering of these two still do matter, okay? Because if you do answer dot next is equal to first, then you're setting at first, and if you do answer dot next is equal to something with whatever, it will mess up the reference. So keep these ordering in mind, right? Ordering really matters when you do linked list questions, because you don't want to be doing next before any other operation that you don't want to do. Then else, like I said, same thing, don't worry, s, and then s equals to s dot next, and answer is just a dot next, right? So now we've pretty much written out our main stuff. So dummy, answer, first and second, val first and second, this to this, this to this, and this to this, right? So we've already gotten that. So if you look at example 3 though, there is one thing that still matters. It is the fact that either list can be shorter than the other. Our first loop strictly states that, well, both of them have to be pointing at something, right? But what if we, let's say s is shorter than f and f still has to process some nodes? Well, then we will have to process those nodes, right? So we'll say answer dot next is back to first, it is the same thing, and first is now sitting at its next, and answer is also pointing to its next. And you can do the same exact thing for s. So answer dot next is sitting at s is sitting at s dot next, answer is sitting at its next, and at the end just return dummy dot next, because our answer has built out the entire list for us now, right? So considering cases when either one of those lists are shorter than the other, considering case when both of them are equal. Lengthy code, but definitely a good question.